Hello everyone. In this video, we are going to see a very interesting question that is related to power. Okay, you have two sources basically. One is alternating source and is purely DC source, and they are connected by 1 ohm resistance. You need to find out the power delivered by the Vs of this particular source. Okay, so the power delivered by the source basically will be consumed by this 1 ohm, and it will go to this 5 volt battery also. So first of all, if I write down the Fourier series expression for VST, for this particular waveform, it has a DC component. So it will have DC component plus it will have AC components also, right? Right. So, and if I just talk about this 5 volt source, this particular source will absorb power because of DC component only. Okay. Because to transfer power, source frequency must be same. So whatever current that will flow in the circuit because of the DC component present in VST, that will deliver power to this 5 volt. Okay. And what is the DC component of this VST? DC component is simply 2 Vm by pi. So 20 by pi. So if I just want to calculate power delivered, power absorbed by 5 volt, power absorbed by 5 volt, I have DC, and this is 20 by pi, this is 1 ohm, and this is 5 volt. So what is the current that is flowing IDC? IDC is simply 20 by pi minus 5 by 1. So this current is simply 20 by pi minus 5. That is 1.366 ampere. So DC current will flow in the circuit as 1.366 ampere. So uh, P5. So P5 is just simply I'm saying that 5 notation means this particular source will absorb, like the deliver absorb power. I'm denoting as a P5. That is simply IDC into 5 volt. So what this is into 5. 6.833, 6.83, sorry, not 833, 6.83091 watt. So I got the power absorbed by the 5 volt. Now what about this 1 ohm resistance? Because if you consider the AC component in the voltage source, and for for resistance the power is calculated by, for resistance power is calculated by IRMS square by R, or Vrms square by R. So either I need to calculate the RMS value of the current or voltage across this RMS value of this voltage across resistance. Okay. So how can we do that? So if I just calculate the, you can say the you can say the current, the RMS current. For that, what I have to do? Let me draw the circuit again. 5 volt, 1 ohm, Vs of t, I of t. 10, right? And yeah, so if I just observe into this first part, or the first cycle, or you can say one period, so my voltage is simply voltage across resistance, let me call it as a VRT, for one time period. For one time period, Vr of t is simply, see this particular, if you see this particular waveform, it is a part of sinusoidal. So if I write this particular expression, so this expression should be 10 sine omega t, and this is valid only for 0 to omega t. pi. So for this duration, this particular equation is valid. So for one time period, the voltage across resistance will be 10 sine omega t minus 5. Now I need to find out the RMS value of this particular quantity. Now how to find out the RMS? See, this particular quantity, it is actually periodic, and this particular nature will also come in the second cycle, third cycle, like that it will come. And what is the RMS value of this particular waveform? RMS value of the individual quantity, 10 by root 2 whole square plus 5 square. So this is the RMS value. So if you calculate 10 by root 2 whole square plus 5 square to root 75. So power across resistance, power power consumed by resistance, that should be PR Vrms square, it means 75 under root whole square by 1 equal to 75 watt. Okay, and the total energy total power delivered with this VST is simply P is equals to P5 plus PR 6.8309 plus 75, 6.8309 plus, so 81.8309 watt. So this is their answer. Okay, so here the key point is, one must know, like, this particular 5 volt will absorb power because of only DC current that is flowing in the circuit, but this 1 ohm will consume or will absorb power because of AC as well as DC. If you just calculate the power absorbed by this particular 1 ohm resistance because of DC component, that will be wrong actually. Okay, so you have to you have to understand how the power flow is happening, because power can only be flow, or power can only be transferred or absorbed when the voltage and current frequencies are same. Okay, and in case of resistance, why I am taking RMS value, maybe I can give one you can say one explanation for that. So let's say you have one resistance and you have one voltage source here, and this voltage source contain harmonic DC component VDC plus V1 sine omega 1 t plus V3 sine omega 3 t plus dot dot dot. Okay, so current flowing through the circuit will be VDC by R plus V1 by R sine omega 1 t plus V3 by R sine omega 3 t plus dot dot dot, right? What is the instantaneous power? The instantaneous power is VDC square by R plus V1 square by R sine square omega 1 t plus V3 square by R sine omega 3 sine square omega 3 t plus dot dot. If you take the average over one time period, you will get, like, the power will be, average power will be VDC square by R, V1 square by R plus V3 square by R, like that it will go. So if you just look into this particular configuration, you can also write down, uh, you can write down like this way: VDC square, VDC square plus V1 square plus V3 square plus dot 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 and whole square. And if you look into this particular expression, it is simply RMS value of this particular voltage source. So for resistance, if you want to calculate power, you must know the current flowing through resistance, or voltage RMS value of the RMS value of the voltage across resistance. So these are two things you must know to calculate power and power consumed by resistance. Okay. From this discussion, if you have any doubt, you can ask in the chat box. Thank you.